Okay, so the third video that we have is the predicting the products. We're just going to start with single replacement. There is going to be a double replacement and single replacement predicting of products, but we'll just start with single replacement. To predict if any single replacement will react, you have to use the activity series. Okay, this is the home record problem, so we're going to talk about this one and kind of how it works. So the free element, in that single replacement, there's a free element and then there's a compound. So the free element must be more reactive than the element in the compound it is attempting to replace. So we got to look here at our activity series. Now this is on your reference sheet. Please go ahead and flip to it now. You can look at it, the activity series. Note that you have the activity series of metals here, which is separate from the activity series of the halogens. These, of course, are going to be your anion pieces, and the anion can only replace an anion. And these are your cations. Your cations can only replace cations. Okay? So if the free element is more active than the element in the compound, then the reaction will occur. For example, and if it's more reactive, it will be higher up in the series. It will be higher up in the series. So you can think about that home record problem is upgrading. You know what I mean? So we have Cl2 plus 2HBr, or chlorine gas, plus hydrobromic acid. We have the two there because they've already started to balance that for you. But you look up here, you say, okay, is Cl able to replace Br? So is chlorine above bromine? In other words, if you look at your activity series, the answer here is yes. So this reaction will be able to happen. So chlorine can successfully replace bromine because it is higher up in its respective activity series. Remember, the halogens are separate activity series in the metals. They do not coincide. They're not together. They're two totally separate series. Okay, but the chlorine, which has a negative by nature, it can replace the negative part of the hydrobromic acid, and because it's higher up, it can do so. Okay, so when you do that, as you can see here, your chlorine then combines with the hydrogen to create hydrochloric acid, and we know doing the correct crisscross, it will be HCl, and then that leaves bromine out by itself, so all lonely by itself. In a single replacement, somebody's always by themselves at the end of this, so bromine vapor, bromine liquid, will be the result here, and that's Br2 signified. Now remember, chlorine is a Hofbrinkel, so in these equations, it's going to be Cl2, bromine is also a Hofbrinkel, so in these equations it'll be Br2, hydrogen will be H2, oxygen will be O2, and so forth and so on. So those are going to show up in those capacities when you put them into the equations when they're by themselves. If the free element is less active than the element in the compound, the reaction will not occur. So if you had bromine out here, bromine vapor plus hydrochloric acid, as we see up here, bromine is not higher than the chlorine piece that it will be replacing. So this will be a DNR, and DNR stands for does not react. So you will not get a reaction if your free element is not higher up on the activity series here based on your reference sheet. So you just got to keep that in mind. Those are the main rules. This is it. I know it seems like a lot, but when you're doing this, you're going to predict it. You should be able to get pretty good at predicting these, what it's going to be based on what you have. For example, and I'm just going to going off a little side to the side right now. For example, if you have two individual elements adding together, that's going to be, or two or more elements adding together to form one compound, that's going to be synthesis. If you have one reactant in multiple products, it's going to be a decomposition scenario. If you have a scenario where you have one free element and one compound as the reactants, that's going to be a single replacement. If you have two compounds as reactants being added together, it's going to be a double replacement. So when we identify, we should have been able to see some of these things. And then whenever you have your hydrocarbon or your carbon hydrogen molecule plus oxygen gas, that that's going to be a combustion reaction. And just remember, combustion is really specific, and so you know what the products are going to be already. You don't have to try to guess them or figure them. You know that they are carbon dioxide and water. Okay, moving forward. So note, don't ever bring a subscript across the arrow unless it's part of a polyatomic ion. So in other words, it's saying if there's like a crisscross that happened and there's a subscript that's a result of the crisscross, Let me go back. For example, this subscript is a result of the crisscross because it's a diatomic molecule. Okay, we're not bringing those across. We had a Cl2, but we're not bringing the two across is what it means there, because when chlorine combines with hydrogen, you have a positive one and then negative one charge. When you crisscross, you'll get HCl. So you're not bringing that 2 subscript across. If it's the result, you want to make sure you're just doing your crisscross method properly. When you're doing your bonding, you just got to put into consideration that you have that happening, and not to bring them over just to be bringing the subscripts over, but make sure that it occurs from the proper crisscrossing of your 2 ions that's going on there. Okay, activity series examples. So here we go. Let's just take a look at a few of these. I'll walk through a few of these with you, and then you can do some on your own. And these are all single replacement examples. So you have Ag plus ZnCl2. And again, this makes sense here. We got to see, okay, silver, is it going to be able to replace zinc? Let's see. We have Ag way down here, and then we have zinc up here. So is that going to be able to happen? No. Why? Because silver is not more reactive. Where'd my arrow go? Silver down here is not more reactive than zinc. Okay, zinc is more reactive than silver, so it's going to be a DNR. Now, if we switch it up and do zinc plus silver nitrate, okay, we know that zinc can replace silver because it is above silver in the activity series. So we'll be able to get some products there. Now, how do we go about doing that? We get our charge on the silver here from the AgNO3. You know silver is an exception to the rule. It's always +1. And you know that zinc here is always +2. These are both exceptions to the rule. So now the zinc is going to be combining with the nitrate ion. So you're going to have zinc nitrate, and then you're going to have silver by itself. Okay, which is going to be the product there. How do I know that? Because you know that the metal replaces the metal portion of the compound. And they even went ahead and balanced it for you. Please note that this, because zinc is +2, NO3 is a -1 charge, you still have to do the proper crisscrossing going on here. So we're not avoiding that. We got to make sure we do the proper crisscross, and that's what's going to be the resultant. We know the zinc ion and the nitrate ion are going to be combining, so we have to just make sure we do that properly. Okay, and then they've already balanced it for you. Okay, here's some more. Zinc and it's like copper 2 sulfate. So when we are looking at this, can zinc replace the copper, right? Because it's about the metal trying to replace the metal. Zinc is up here. Where's copper? Oh, it's down here. Is that a go? Yes, it is. So we're now going to then combine our zinc +2 ion with our sulfate -2 ion. Again, it's a 2-to-2 ratio. So there's going to be a reduction there. So you will get copper by itself, and then you will get zinc sulfate. So copper plus zinc sulfate should be your product here. Now, if you're having difficulty kind of following me on what I'm doing, all I'm doing is if you want, you can write the ion right below here. So zinc is going to have a +2 charge. You can write that down here. The copper, based on this copper 2 sulfate molecule or compound, it's going to be copper 2 because sulfate has a -2, and there's no 2 right there, right? So it's a 1-to-1 ratio because there's no parentheses around the sulfate. So you know that it was supposed to bring out a 2 is because this was originally copper 2. So we have that Cu2+, and then we have sulfate, the SO4, which has a 2- charge. So we combine our Zn +2 with our SO4 -2, we'll get ZnSO4, and then plus copper. And there you go, with no parentheses needed because that had reduced from a 2-to-2 to a 1-to-1. All right, NaCl plus lithium. Lithium is way at the top, so lithium is going to be able to replace just about anything, but not be replaced. So if you see lithium up there and it's the free element, you know that's going to happen. So lithium is then going to combine with your chlorine now because it's taking the place of sodium, Na. So now we're going to have a lithium chloride as our product, and then sodium will be out by itself. So we have to make sure we properly are comparing that. And so when we're looking at this, we got to make sure we look at our lithium, which is a +1 charge, and our chlorine, which is a -1 charge. That's a good solid 1-to-1 ratio there. And, so you get LiCl plus Na on that one. Okay. I'm going to go ahead and have you go ahead and work out the rest of these. And then I have a predicting products activity for you, in which I would like for you to try to attempt to predict the products. You're going to have some equations, just the reactant part, and you're going to have to try to figure out exactly what each one is. Now, you know the characteristics of each one, so you know what the reactants should look like for each type of reaction. So you want to make sure you're trying to predict, what kind of reactions, what type of reaction is this based on the reactants? Okay, it looks like it's going to be one of those. And keep in mind, on your reference sheet in particular, there's a part on here where it tells you on page 6, specifically, it tells you how, for some of these compounds, how they will break down exactly. You really want to pay close attention there to the bottom of page 6. It tells you synthesis, decomposition, single replacement, double replacement, combustion. So, you have this handed to you on a platter on page 6 at the bottom. The only thing you have to do is just pay attention to what cases things are happening, and you're able to look there at each of the ones. So this is given to you. This is on your reference sheet. You can use your reference sheet on everything. So this is a great tool for you to use. Please don't forget to use that. It's awesome. So with that being said, I'll shoot another video of kind of how to go through the predicting products just to get you started, so that you can start to do that. And again, if you have any questions, please make sure you save it to when I return to class, and then we can make sure to go over the details of all these types of reactions and balancing and being able to predict the products. And you guys are just working your way right on through reactions. So I'll see you when I get back. And take care and good luck, and go ahead and just try that predicting the products and see how far you get. And if you come across the double replacement stuff, just hold off on that. We'll save that for when we get back.